Hello again and welcome to the Medication Mathematics course. In today's session, we are going to continue our discussion on how to calculate flow rates. Today's presentation will be focused on calculating the flow rate in GTT per minute or drop per minute using the drop factor. Remember that we said to be able to calculate for the drop per minute flow rate, we have to have the drop factor. Let's begin by solving a sample question. The provider has prescribed 500 ml of 5% dextrosaline to be infused over 6 hours. The nurse obtains a primary IV set that delivers 10 drops per ml. What will the correct rate of flow be? And so we are going to go through 4 simple steps to do this calculation. So step 1, as always, we have to decide or determine what variables we have in the question. Going back to the question, we know that we have a volume of 500 ml. This is to be infused over a time of 6 hours, so we have 6 hours. And then our drop factor, which I will designate by F, is 10 drops, which is GTT per ml. So these are the variables in our question. Next, we have to determine what the question is asking us to find. So that will be the final required unit. It's asking us to find the drop per minute. Note that the drop factor is drop per ml and not per minute. That is why we have to calculate for the drop per minute. The next step will be to calculate for the rate in ml per hour, and using our formula we know that if we want the rate, R is going to be the volume divided by time. So in our question, this is going to be 500 mLs divided by 6 hours. So when we compute this in the calculator, we are going to have 83.333, and this 3 is going to be recurrent. And so we are just going to leave it as that. Do not round off your answer at this time. Let's go to step 4. Then we are going to find the rate in ml per minute. The rate in ml per minute. Okay, so to do this, we said we are simply going to divide our rate in ml per hour by 60. So we know our rate of ml per hour to be 83.3333 recurrent ml per hour. Let's divide this by 60, and we are going to get 1.388833. Okay, so this will give us 1.3888, and it is safe to leave our answer to 4 decimal places. And so this will be our ml per minute. Once we have this, then we will go to the next step. Multiply your rate in ml per minute by the drop factor. So we know that our rate in ml per minute is 1.388 ml per minute. When we multiply this by the drop factor, which is 10 GTT per ml, we will see that this ml will cancel this ml. And now we have 13.88 drops, so GTT per minute. Now the question said we should leave our answer to the nearest whole number for drop factors, because you cannot count 13.88 per minute. So what we are going to do is locate the number after the decimal place, and that will be our 8. And then determine if this is greater than 5 or equal to 5 or less than 5. We said if it's less than 5, we just basically drop everything after the point. If it is equal to or greater than 5, then we are going to round up our number before the decimal place. And so because 8 is greater than 5, we are going to round our number before the decimal, which is 3, up by 1, and that is going to give us 14 drops per minute. So our final answer for this question is going to be 14 drops per minute. Why do we need to know drops per minute? With the invention of pumps, basically all medications are on electronic pumps now, but when you go to other countries, or in case of, say, a weather storm, when all the power is out, you should be able to do your calculations using the drop factor. Now let's use dimensional analysis to solve and combine all the steps. Okay, so we know our variables. Okay, we know that we have 500 cc's or 500 ml. This is to be given in 6 hours. But for every hour, we know that we have 60 minutes. Okay, so hour will cancel hour. Now we have ml per minute. Then we know that we have 10 drops per every ml. So ml will cancel ml. Now remember, what did we desire? We desired our answer to be in GTT, which is drop per minute. So the units that are left here is GTT per minute, which means that we set up our equation or our dimensional analysis correctly. Okay, so each of these means multiplication and this line means division. So we are going to cancel out. So we can cancel out zeros. And now we have 500 divided by 6 times 6, which is 36. So 500 divided by 36. And when we compute this in our calculator, we are going to get 3.88. Leave this in the nearest whole number, and because 8 after the decimal point is greater than 5, we are going to round this number before the decimal place, or that's decimal point up, and this is going to give us 14 ml per 14 drops per minute. So GTT per minute, and this will be our desired answer. So you can see that when using dimensional analysis, we can combine all the 5 steps into one step by putting all the components or variables on one sheet. Let's do another question. So what if you have the rate already? If you have the rate already, then you are just going to skip step 1 through 3. And if you want to use the ratio or formula method, then all you will need to do is, if you have the rate in ml per hour, divided by 60. So in our question, we have 1,000 ml of D5 half normal saline at 75 ml per hour. This is important to note. Is the rate in ml per hour or ml per minute? If it's ml per hour, we have to find the ml per minute. If it is ml per minute, then we just multiply it with the drop factor. Okay, so we have 75 ml per hour, and we have to divide this by 60 minutes in, remember, in 1 hour. So this can also be written as 75 ml per hour times 1 hour over 60 minutes. So hour will cancel hour, and 75 divided by 60 will give us 1.25. So we have 1.25 ml per minute. Okay. Then all we have to do is multiply this by our drop factor to get our drop per minute. So we know that we have 1.25 ml per each minute. Multiply this by the drop factor, which is 10 drops per each ml, and ml will cancel ml. So now we have 12.5 drops per minute. But we have to convert this to the nearest whole number, and because the figure after the decimal point is equal to 5, we are going to round this number before the decimal place up. And so this is going to give us 13 drops per minute. And this will be our final answer. Now, let's use dimensional analysis to solve this same question. And so, when using dimensional analysis, is basically going to be similar. We already have the drop per hour. I'm sorry, the ml per hour. Come on. So we're going to draw our track. We have 75 ml per hour, and we know that in every 1 hour there is going to be 60 minutes. And then we know that for every 10 drops, we are going to have 1 ml. So let's cancel out the units and see if we set this up correctly. ml will cancel ml, hour will cancel hour, and we have drop per minute. So multiply the top numbers, we will get 750. Multiply the bottom numbers, we will get 60. And then we can cancel 0, and we have 75 divided by 6. So 75 divided by 6 is going to give us 12.5. Round this up to the nearest whole, and we are going to get 13 drops per minute. So in this review, we have shown that you can do the drop per minute calculations using the drop factor in either 5 steps, or you can use dimensional analysis where you have all your components in one calculation. Keep practicing and see whichever method is easier for you, and master that method and you will be good to go. Thank you for watching this session. I will see you in the next presentation. Take care.